Okay, so we are going to solve, or be solving a system of equations. Put that in there, of equations by elimination. Sometimes it's also called linear combinations. Okay, so I'm going to do a few examples today. So let's start off with example 1. Actually, I might give you a couple steps first. Let's do some steps. The first thing you're going to want to do is probably have it in standard form. A lot of times that is the easiest way to do these. So have both of your equations in standard form. And then you're looking for coefficients that are exact opposites. So example, if you had a 5y, then you'd want the other one to be a negative 5y. If you have 2x, then you would want the other one to be a negative 2x. Okay? And then after you get that, you're going to make the system a big addition problem. Okay, so let's do that first. So the system that we're going to start off with is example 1. We have 2x plus 5y equals 9. When we're doing solving by elimination, I like to put them up and down on top of each other, as opposed to if I'm doing substitution. I like them side by side because I'm drawing arrows all over the place. So 2x plus 5y equals 9, and 3x minus 5y equals 1. So what I'm looking for is coefficients that have the exact opposites. So I have a 2 and a 3. Those definitely aren't opposites. But here I have a 5 and a negative 5. So a positive 5 and a negative 5. When I have that, I'm ready to turn this into a really big addition problem. And then you're going to bring everything down. So what is 2x plus 3x? It is 5x. 5y minus 5y, hence the name elimination. So you better eliminate a variable as soon as you change it to a big addition problem. Bring down your equals. 9 plus 1 gives you 10. So right now we have 5x equals 10. Divide both sides by 5. And we have half of our ordered pair already, which is x equals 2. Just like what we did in substitution, we're going to take that and plug our value of 2 in to one of these two equations. I'm going to choose the bottom one, just because I think the numbers are a little bit smaller, like that 9 and the 1, but it would not matter. So I have 3 times my x, I'm saying is 2, minus 5y equals 1. 6 minus 5y equals 1. Solving for y, subtract 6 on both sides. Don't forget to bring down that negative. Negative 5y equals negative 5. Do the inverse by dividing both sides by a negative 5. 5's cancel, negatives cancel. Anything divided by itself is 1. So my ordered pair is 2, 1 for my final answer. And again, I can check it fairly quickly. I'm going to put my check over here. So 2 times 2 plus 5 times 1 equals 9. I'm going to do this in my head. 4 plus 5 equals 9. 9 equals 9. So it checks already in the first one. Put it in the second one. 3 times my 2 minus 5 times my 1 equals 1. 6 minus 5 equals 1. So 1 equals 1. It checks, so I know 100% that my answer is correct. Let's do the second example. So I have 3x minus y equals 13. And I have 5x plus 2y equal to 7. So again, we're looking for the opposite coefficients. 3 and a 5, not even close. Okay, well this is a negative, and this is a positive, but this is a 1. So what could I do to this term that's going to be the opposite of this one? So if I took this times 2, wouldn't this be a negative 2y and this would be a positive 2y? I'm going to multiply every term in that particular equation by 2. So I'm going to clean it up. 6y minus 2y equals 26. The most common error is people forget to multiply the 2 times the 13 as well. I'm going to bring over, oopsie, this should be an x. My mistake. Bring over my other one of 5x plus 2y equals 7. Now we're right back to where we were. We have a negative 2 and a positive 2. So that's going to be the variable I'm going to eliminate. Turn it to a big addition problem. 11x equals 33. So x equals 3. Put that into, I'm going to put it into the bottom one just because there's no negatives there. So 5 times my x of 3 plus my 2y equals 7. 15 plus 2y equals 7. Subtract 15 on both sides. And I get 2y equals negative 8. And then divide both sides by 2. And I get y to equal a negative 4. Putting this together as an ordered pair, I have an ordered pair of 3 and negative 4, and I should check it. Last example that I want to do, let me see if I can find a good one. Let's see. Let's do 5x plus 4y equals negative 14, and 3x plus 6y equals 6. Okay, so I can't just multiply one of these by a number and get the opposite coefficient. So I could do this two ways. I could try to eliminate the x's by figuring out what number does 5 and 3 go into, or I could eliminate the y's and figure out what 4 and 6 go into. I'm going to go ahead and just do the y's just because. So what is a number that goes into 4 and 6 both go into? Let me say that again. What's a number that 4 and 6 both go into? Not a number that both goes into them, but what do they go into? They both go into 12. So my goal is to get one of these to be a positive 12 and one of these to be a negative 12. And again, it does not matter. So I'm going to multiply the top by 3 every single term. So I have 15x plus 12y equals negative 42. So if I got a positive 12 here, I would like to have a negative 12 here. So that means I'm going to have to multiply everything by a negative 2 in the bottom equation. So I have negative 6x minus 12y equals negative 12. Notice I have opposite coefficients. So we're ready for a really big addition problem. 15 minus 6 gives me 9x. Y's are going to eliminate, equals negative 54. So x equals a negative 6. So there's half of my order pair. I'm going to always go back to the original, and I'm definitely going to pick this bottom one because the numbers are much smaller. Now I need to find my y. I'm going to add 18 to both sides. So 6y equals 24. Divide both sides by 6, and I get y equals 4. My final answer is negative 6 and 4. And again, I should check it. Oops, sorry, I ran out of space there.